Good morning, welcome to the 2021 Facebook Hacker Cup Round 3 and the solution video to problem A, reporting. So in this problem, Facebook is an ore mining company and they have n employees numbered 1 to n, where 1 is the most senior employee and n is the least senior. You want to avoid future accidents by assigning some shift partners between pairs of employees, and when 2 employees become partners, they can give reports to each other. Now, you can also give a report from 1 employee to another if either you have some chain of partners between them, or you can give it a report from 1 employee to another if you are of higher seniority. So in other words, you have a lower index. So let's do a quick example here. Let's say you're person 5 and you want to give a report to person 2. Maybe you're friends with person 3, and then you also know person 1 is friends with person 4. What that tells you is that you actually can give a report to person 2, even though they're a much more senior employee than you, by asking your friend of 3 to ask your friend of 4 to ask the person of index 1 to ask person 2 for the report. So you can follow this chain here, and then you can give person 2 the report from person 5. So this is an example of 1 pair. 5 can give a report to 2. Of course, 2 can also give a report to 5 because 2 is more senior than 5, so 2 can just very directly give a report to 5 as well. You want to know how many pairs are there after each step of creating these partnerships. So to actually solve this problem, it can be helpful to consider which groups of employees are there where every employee in this group can give a report to every other employee in this group. If we think about this problem as a directed graph problem, this would be exactly the definition of a strongly connected component. So maybe we have just 1 edge here, and it's this edge. In other words, this is the only pair that's been made. What that means is, now of course 5 can give reports to 3, 3 can give reports to 4, and 4 can give reports to 5. So this makes a strongly connected component here. Now if we want to add 1 more edge, say we want to add an edge from 3 to 1, what this would do is, again, what you've noticed is in this first step, we have combined 5, 3, and everything in between all into the same strongly connected component. So now we want to do the same thing here. We want to combine 3, 1, and everything in between into the same strongly connected component. Instead of doing it in that order, we can do it a little bit easier. We can say combine 3 with the thing above it, and keep doing that until 3 and 1 are in the same component. So more naively, we could first have this SCC, then we could join the 2 into it, and finally, we could join the 1 into it. And we just want to be able to merge things into the same strongly connected component and maintain how many pairs are there of people where A can give a report to B. So we'll talk about how to do that right now, actually. So in order to repeatedly do this, what we can use is a disjoint set, which stores all of the groups of people which are in the same maximal group where everyone can report to everyone else. So initially, everyone will be in their own part of the disjoint set, but then when we add this first edge here, what that tells us is we need to take 5, the smaller or the more junior of the 2 elements, and union it with the thing before it. So we look at the 5, we find the smallest thing in its group, which is 5, and we union it with the 4. So now we have something that looks like this. When we did this, we have 1 thing in this group and 1 thing in this group. So we've increased our total number of pairs by 1 times 1. So we've added 1 pair here. Now we take the smallest thing in the smallest index in this group, which is the 4, and union it with the thing above it, which is 4 minus 1 or 3. So we'll union these 2 together. When we do this, we create an additional 1 times 2 pairs of people who can be reports. In other words, that is plus 2 to the total number of reports. And then say after this, maybe we want to add this edge here. Let's do a more complicated one. So maybe we want to add this edge. Now we don't naively want to join 4 with 3 and everything before that because that would be n squared. They might all be in the same group. So instead, to speed that up, what we can say is let's find the smallest thing in this group. And the smallest thing in 4's group is currently the 3. And then merge 3 with 3 minus 1. So merge 3 with 2. And keep doing that until 4 and 2 are in the same set. So we find the 3, we find the 2, which is 1 less than the 3. We merge these into the same set. And we get something like this. And in total, the size of 2 is 1. The size of this component is 3. So we have created plus 3 times 1, which is 3 new pairs, which now exist but don't. And the 3 times 1 comes from you have 3 things here, each of which can now give a report to anything in this group of 1. So to implement this, we need a disjoint set that stores the size of each component and also the minimum index of all things in that component. And when we assign, one parent of the disjoint set group to the other, we can just make sure to maintain these 2 values. So the final runtime is just the runtime of a disjoint set, which is inverse Ackermann, or in practice about 4 times the number of events, which is n. So roughly your runtime is basically order n, although technically it's n times inverse Ackermann. Thanks for watching. Hopefully that was helpful. And hopefully with this new information, you should be able to upsolve the problem if you weren't able to get it in contest. Goodbye.